Okay, it's page 4, this is exam 2 again. Use the table of f of x and g of x to compute the derivative. So here's our table for f of x. This is our graph of g of x. So our first question asks for the derivative. So d over d of x for 2 f of x minus g of x minus 1 x minus 1 over x. Let me double check that real quick. It should be 1 over x. Yep, 1 over x. Should be squared. Okay. At x equals 2. So for this one we find the derivative. This would be 2 of f prime of x minus g prime of x. And derivative of 1 over x would be derivative of x negative 1. Derivative, this would be negative 1x, 1 minus 1, which is negative 2. You're going to have negative x minus 2. Rewrite that again. This is going to be 1 over x squared. So, derivative of 1 over x would be plus 1 over x squared. So this is negatives, turn that to positive. So x is 2, we plug in for each value. So 2 of f of 2. f prime of 2 minus g prime of 2 plus 1 over 2 squared. So at x values, we look for 2. So here's 2. And at f of prime, we have negative 4. So 2 times negative 4 minus. So g, for this one, g of prime would be again the slope. So we look at the slope at 2. At 2, there's a direct cusp, which means there's no definite slope. So that means the point does not exist. The slope does not exist. Plus 1 over 4. Immediately right away, since you have does not exist, the derivative of 2f minus g minus 1x does not exist, because at g prime of 2, the point does not exist. So, first one would be does not exist. Now next one is to look at d of x for x over f of x at x equals to 0. In this case, to find the derivative of x over f of x, you use the formula low d high minus high d low over low squared. This means you take the derivative, or you take the denominator, so f of x, which is your low, times your derivative of the top function, which is x, so the derivative of x is 1, minus x, since it's the top function, minus the derivative of the bottom one, or times the derivative, so it would be x times f prime of x over fx squared. Let's double check that on my end. Yep. Should be actually squared on this whole side actually. I just realized that. So low d high and high d low means you take the low, you take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared, which is what we have. So low again is f of x. Our high, derivative of the high would be 1 minus x times the derivative of the low of the denominator, which is prime of x, all over f of x squared. Now we can plug in our values at x equals to 0. So our equation would be f of 0 times 1 minus 0 times f of 0, f prime of 0, over f of 0 squared. So at x equals 0 for f of x, we have 2. So 2 times 1 minus 0 times, so at 0 again, we look at the f prime of x. So 0 times, so it would be 4. So 0 for f prime of x is 4. Going back to this, f of 0 would again be, so f of 0, so 0 would be 2. So we have f of 2, oops, we don't have f of 1, we just have 2 squared. Now we're able to simplify. So 2 times 1 is 2, minus 0 times 4, which is 0, so you can just cancel that out. Now you have 2 squared, which is 4. Simplify that, you have 1/2. So the derivative of x over f of x at x equals 0 is 1/2. Our next and last limit would be f of g of x at x approaches as x equals -3. So then what we'll do first is look what's inside. So we have, first we find the derivative of this. So we find derivative of f of g of x, which is a chain rule. So that would be f prime times g of x times g prime of x. So now we can plug in the values. So first we look into what's inside first. So we have f prime times g of 3 times g prime of -3. Should be -1. So -3, so g of -3 is 0. Times, so when it's g of x, you're just looking at the point, but when it's g prime of x, you're looking at the slope. So the slope of g prime at -3 would be 3, because you're going up 3 and 1 across. So up 3, 1 across, which is 3 over 1, which is just 3. The same for this side, you're going up 3 and 1 across. So then your g prime would be 3. Now look back at f prime of 0. So at 0, look at f, which is, so the x would be 0, and at f prime of x would be 4, because that's our x value. So we have 4 times 3, which is 12. And this is our derivative for f of g of x at x equals 3. The centroid is a bit complicated to use, but we first need to look at is that if it gives you the x value, you look at the corresponding x value, and depending if it's f of x or f prime of x, you look at these values. And once again, it's important to know, so if you're given like a graph and you have g of x, you're looking at just the points, where the point is at. If you're given g prime of x, you're looking at the slope of the point. And for points like this at x equals to 2, when it's a sharp turn, this is a cusp, there's no slope. Same thing if it's a steep incline, there is no slope. Or actually, this is a corner. Yeah. So a corner is like when it just takes a sharp turn. A cusp is when it curves and then straightens out. That's a cusp. Either way, these have no slope, so then the point of that slope does not exist. Which is why A does not exist. Because G prime at 2 would be a corner. So